Good day, everyone. Today, I will be discussing biotechnology based on the module released by Biodiversity International titled Law and Policy of Relevance to the Management of Plant Genetic Resources by Brogdon et al. 2005. Biotechnology. The Biodiversity International has released a module titled Law and Policy of Relevance to the Management of Plant Genetic Resources by Brogdon et al. 2005, which aims to help professionals in managing, conserving, and using plant genetic resources for food and agriculture. The module provides the following definitions. First, biotechnology uses biological systems, living organisms, or derivatives thereof to make or modify products or processes for a specific use. In simple terms, it means using life or parts of life to produce something useful. Biotechnology is applied in food, agriculture, medicine, and industry. It helps us improve efficiency, speed up production, and create safer or better quality products. Examples include: first, producing insulin using bacteria. Scientists place the human insulin gene inside bacteria. The bacteria then produce insulin that is used by diabetic patients. Second, making yogurt and cheese. Microorganisms like bacteria help ferment milk, turning it into dairy products. Second, genetic engineering is a technique that allows genes and DNA to be transferred from one source to another. It leads to the production of living modified organisms or LMO or genetically modified organisms GMO. In simple terms, genetic engineering is a specific technique under biotechnology where scientists transfer, modify, or insert genes or DNA from one organism into another. This leads to the creation of living modified organisms or genetically modified organisms. Genetic engineering allows organisms to gain new traits such as resistance to pests or improved nutrition. Examples include: first, Beta corn. A bacterial gene is inserted into the corn so that the plant can defend itself against pests, reducing the need for pesticides. Second, golden rice. This rice is genetically modified to produce beta-carotene, which is converted to vitamin A. It helps reduce vitamin A deficiency in many countries. Third, modern biotechnology gives scientists molecular tools for obtaining a better understanding of the structure and function of genes and living organisms. In simple terms, biotechnology uses advanced molecular tools like DNA analysis, gene editing, and molecular diagnostics to better understand genes and how living organisms function. Through these tools, scientists can study life at the molecular level, identify genetic problems, and create solutions that were not possible before. Examples include: first, DNA fingerprinting. This technique identifies people using their unique DNA patterns. It is widely used in forensics, criminals, investigators, and paternity tests. Second, gene therapy. This method replaces faulty genes with healthy ones to treat certain genetic disorders. So, modern biotechnology paves the way for new developments on food and agriculture. Particularly, it aims to develop new precision tools and diagnostics, speed up breeding gains and efficiency, development pest and disease-resistant crops, combat salinity, drought, and problems of agriculture, enhance the nutritional quality of food, increase crop varieties and choice, reduce inputs and production costs, and increase profits by Brogdon et al. 2005. Role of modern biotechnology and food and agriculture. Modern biotechnology has a major impact on improving crop production and agricultural practices. It allows scientists to create crops that are healthier, more nutritious, and more resilient. In summary, modern biotechnology supports sustainable agriculture, improves food security, and helps farmers produce more with fewer resources. That ends my report on biotechnology. Biotechnology continues to shape our world by improving health, food production, and the environment. Understanding its concepts helps us appreciate how science and innovation address global issues today.